2018 OL paper, DT graph, distance versus time graph. Okay, let's analyze this graph first. Okay, it's very easy to analyze here. This is going with the uniform speed. Then here the distance does not change. Oh, so at this place, okay, at this region, the vehicle was in rest. Okay, that is in rest. So that's why the distance does not change. Okay, if they were traveled a little, the distance should increase. No, here you can see from the starting to end, the distance is 6 kilometers. So that means in this 20 minutes they took some rest. Then after they they used to go in another uniform speed. That's the thing. That's the way you should analyze this graph first. Then after, let's apply the things which we discussed over here. For how long did the student stop in between? Okay, a student traveled from his home to school is shown in the given distance time graph. Okay, students. That student was traveling and took some rest, then after also traveling. So how long did the student stop in between? In this region, that student got stopped. Okay, so the time is in minutes. It would be 50 to 30, not total 50 minutes. Okay, started from 50, started from 30 up to 50 minutes. She took some rest, so the time would be 20 minutes. Okay, 20 minutes. 50 minus 30, that would be 20. 20 minutes. That's the way you should answer your first one. Let's try to answer the second one. Find the speed at which he traveled during the initial 30 minutes in kilometer per hour. Okay, initial 30 minutes in kilometer per hour. Okay, initial 30 minutes, we have to find the speed. Okay, to find speed, you should divide distance by time. Distance divided by time, that would be our speed. The distance in this region, distance traveled was 6 kilometers from 0 to 6. So 6 kilometers within the time 30 minutes. Okay, 30 minutes. But our question is to find in kilometer per hour. Distance already in kilometers, 6 kilometers. So we can substitute as it is. But the time was given in minutes now. So you should convert minutes to hours. Minutes to hours. 30 minutes means 30 divided by 60, that would be 0.5 hours. 0.5 hours. So I'll substitute that one here. Time would be substituted as the measurement in hours. So 6 divided by 0.5, that will give you 12 kilometers per hour. 12 kilometers per hour. That's the speed in the initial 30 minutes. Then let's try our third question. What multiple of the speed at which he traveled in initial 30 minutes is speed at which he traveled in the final 20 minutes? Okay, they are asking us to compare these two speeds. Okay, we found the initial phases, the speed was 12 kilometer per hour, and again they are asking that at which he traveled in final 20 minutes, last 20 minutes. Okay, last 20 minutes of his travel, this is the one. Okay, I'll use another color, green color. Okay, here also we have to find the speed. So to find the speed at that region, distance divided by time. The distance was, okay, up to 12 kilometer, but not exactly 12 kilometer. The student already traveled 6 kilometers. No, so from 6, she took some rest for 20 minutes. Then after, from 6 kilometer onwards, she already traveled 6 kilometers. Furthermore, she is traveling up to 12 kilometers. So the distance she covered now, that is only 6 kilometers again. Why? I'll repeat again. Started from 6 kilometer, end up at 12 kilometers. So what is the difference in between? Not 0 to 12. Okay, started from 6 and up to 12 kilometers she was traveled, and the time she took, that was 50 to 70. 50 to 70, that means in between the time difference, that was 20 minutes. So you should substitute 20 minutes as a hour measurement. Hour. Okay, in hour, let's substitute that one here. Hour. So 20 minutes should be divided by 6. So that will give you 1 upon 3. Okay, 1 upon 3 hours. So I'll divide this. 6 divided by 1 upon 3 hours. So division means that will become a multiplication. Okay, 6 divided by 1 upon 3. So the division, that's not a division furthermore. So we can make it as a multiplication, multiplied by 3 upon 1. So it would be 18. 6 times 3, 18 kilometers per hour. 18 kilometers per hour. Likewise, you should find the speed at this region also. Here the speed was 18. In initial 30 minutes, the speed was 12. Now, let's read the question again. What multiple of the speed at which he traveled in initial 30 minutes is a speed at which he traveled in final 20 minutes? Okay, which multiple? Which multiple? 18 is which multiple of 12? That's our question. So to find that, in last 20 minutes his speed was 18. That should be divided by the speed in initial 30 minutes. That would be 12. So the multiple would be, when you simplify this, that will give you 3 upon 2. Okay, 3 upon 2. 3 upon 2, or you can convert it as a decimal one also. 1.5. That is the multiple. Okay, I'll read again. What multiple of the speed at which he traveled the initial 30 minutes is the speed at which he traveled the final 20 minutes? So final 20 minutes we found the speed as 18. No, 18 is what multiple of 12? That's our question. So 18 divided by 12, that will give you 3 upon 2. So 3 upon 2, that's the multiple. That's the way you should find the multiple. Now let's talk about our last question. If he traveled the whole distance without stopping, okay, without stopping, in the same speed at which he traveled in initial 30 minutes, draw a relevant graph on this figure itself. Okay, now the question, I'll raise these things. Okay, now what they are talking, if he traveled without stopping, okay, without stopping in the same speed at which he traveled in initial 30 minutes. Okay, so if we started to go like this, okay, this is the straight line. Okay, started from here going up to here. Okay, going up to here, and without stopping, if the student was stopped, the curve should be like this. Without stopping means you should extend the same graph until it reaches 12 kilometers. You should extend the same graph until it reaches the 12 kilometers. Likewise, you should extend this graph. That's our question. If he travel the whole distance without stopping, okay, whole distance without stopping, that means you should extend the same graph like this. Okay, the same graph should be extended up to here. That's the graph you should draw. Okay, then after, in case, how many minutes earlier would the student be able to complete the journey? Okay, how many minutes? Without stopping means do not consider about both two speeds and two such regions, and there is a region of stop. Likewise, okay, you should consider about the total one. Started from 0. Her goal is to complete 12 kilometers. Okay, without stopping, she is going with a uniform speed of 12 kilometer per hour. She's going like that. Okay, she's going like that. At the at which place this is intersected with this 12, you should extend that one. That is exactly at 60 minutes. Exactly at 60 minutes. That means she started to travel 12 kilometer per hour and took 20 minutes break. Then after 18 kilometer per hour, in that phases, she will take 70 minutes to travel from home to school. Okay, 70 minutes to travel home to school. She didn't stop anywhere. Okay, started from here to without stopping when she traveled by using a uniform speed. So she will be able to reach the school within 60 minutes. Okay, within 60 minutes. Now question, in this case, how many minutes earlier would the student be able to complete the journey? So initially 70 minutes. Okay, she took, according to the graph, earlier she took 70 minutes, but when she traveled by using a uniform speed, she will reach within 60 minutes. So she will reach 10 minutes earlier than previous 10 minutes earlier than previous. This is the way you should answer the question.